Welcome to the panel at the Agile Meets Architecture. We intentionally kept the focus of this conference to what this conference is about, to Agile, to modern organization stuff, to software architecture. But there's, of course, an elephant in the room, and some talks did already address the elephant this time. And yeah, that's what we are doing here on the panel. So we will be talking about this elephant and about the AI and how it's going to change our industry. If all the AI optimists will be right, then probably the way we are doing or we are organizing software development and software architecture will change fundamentally somehow in the next time. If they are right, we might discuss about that. So that's why we do the panel. That's why I invited the people. Usually I would say, I invited a lot of experts in this field to talk about the field. Well, honestly, there is really no expert on this field. And there's really no expert. So even if somebody claims on LinkedIn he's an expert in this field, he's just lying. Nobody knows about it, really. But still, we have invited some very nice people that are very experienced in our industry to discuss this today. And yeah, maybe just introduce yourself and please quick, we have a lot of topics to cover.
Oh yeah, it's on. Hi, I'm Birgitta. I'm a distinguished engineer at ThoughtWorks, and I'm a domain expert in effective software delivery, and I'm trying to figure out how to use AI in that domain.
Hi, I'm Daniel Terhorst-North. I've been kicking around the computing industry for about 35 years or something. I spent a lot of that writing what we would now call artisanal software with my actual hands. And I think I'm the token grumpy person on the panel. I'm grumpy that this tiny, tiny, tiny niche of AI called LLMs has co-opted the term AI, which is a huge, rich, exciting, vibrant field. I'm grumpy that people think there's $1 trillion industry to be had and they're convinced that we don't need junior developers. I'm grumpy about many things. I'm sure they'll come up. But yeah, so I've been around software and people and teams and organizations for a while. And I'm not sure why I'm on this panel. I know nothing about LLMs, but I'm prepared to have an opinion because I'm a middle-aged white guy.
Yeah, hello, I'm Silvia Schreier. I'm working as principal engineer and architect currently at Intersport. I have experience in retail and wholesale for about 10 years now, mainly with a focus on web architecture and building software, but also building organizations. So yes, AI is changing how we're working, and I'm looking forward to the exchange.
I'm Aino Corry. I'm the grumpy old woman. I am... Besides all the other things that I'm doing, I'm also teaching the teachers in computer science how to teach computer science to the computer science students, which is becoming really interesting with AI. So I'm optimistic and extremely worried.
Hi, I'm Emily Bache. I'm a technical coach. I'm an independent consultant, and I'm very interested in test-driven development. I've been teaching it these past 25 years, and it seems to have fundamentally shifted in just the past few months, and it's turned into something else, which is very exciting and very scary.
Okay, great. So already quite some interesting topics that you teased on here. I only have 6 questions, but I already learned that I'm very optimistic that we will discuss them all. We'll start with the title of this panel, which we chose a few months ago because there was a trend, and still there is a trend, which is called spec-driven development, which to me sounds suspiciously like back to waterfall, because if you specify all the things very well, then the AI will do the rest after it. Birgitta, you wrote a pretty nice blog post, and pretty popular blog post, which is cited quite a lot about this topic. So are we going back to waterfall? What's your take on that?
Yeah, it's interesting because that article gets shared a lot in a way like, oh, look, I did it like that article describes, but I actually have a lot of open and critical questions at the end of the article about this topic. But yeah, I think I see kind of like both directions happening in some way. Like one is this like, yeah, more pull towards waterfall. I recently caught myself thinking about the V model. And I was like, oh my God, what's happening? So kind of this, yeah, we're like, I see Eric there. Eric, you wrote like, I don't know, a year ago about like, are we just trying to do offshoring again, right? If only we write the right specifications, give it to something and then verify afterwards. So there's definitely this trend of like just writing, again, figuring out how do we just write better specifications, which we've actually learned that we're not good at, but you know. So that's the one pull, but then on the other side, I've recently also seen people discovering that when you want to create a lot of throughput, you have to do all of these things like automation, continuous delivery, or I saw this thing about somebody saying, oh, the SDLC, which is actually like Simon was talking about today, is a very waterfall term, right? That has had a resurgence with AI. And this person was writing about, oh, is the SDLC collapsing? Do we not need detailed requirements for the developers anymore because they can do them with AI now? And I was like, but, you know, shouldn't a story always be a placeholder for a conversation? Shouldn't that have always been the case? So there's some people actually discovering these things that I think are actually good ideas that you have to do to get good throughput and good feedback loops. So there seem to be both of those things happening at the same time. Maybe speed run to rediscover good practices. I don't know. Hopefully that's where it will keep going.
But are there also reasons not to do it this way?
Not to do it with the,
let's say, spec in the beginning and then just, well.
Yeah, I think it's ultimately it's all about feedback loops, right? And I still think working in small batches is valid. But because we have this increased level of automation now, I was talking about this today as well, right? That people try to reduce the supervision by the human, and then you have like much longer feedback loops, right? Like an agent going away for 20 minutes, 30 minutes, and then you have like lots of stuff to verify, lots of things that can go the wrong way in between. So I still think small batches in some way are still super valuable, and for that you would still have to have small specifications in a way, right? So, yeah.
So still agile.
Yeah, can I pick up on this with reference to test-driven development? Because this is the kind of premise of TDD is that you learn during the development process, and you use that to adjust what you build. So spec-driven development, if you don't have that feedback during the cycles, then you're missing out. But what I have observed now with TDD practitioners, I mean, I talked to about half a dozen technical coaches who I know and trust and know that they were doing TDD in the before times, and they've all adopted agentic coding now. And they all told me, we are not writing any code by hand anymore. And I'm like, that is huge. You know, what even is TDD if you're not writing the code by hand? And some of them were doing a bit of refactoring. Some of them said, I do some refactoring by hand, particularly preparatory refactoring, but not the coding part, because the agents are so good at that. But what has remained, so I've kind of questioned them, what does your process look like? And what has remained is the short cycles that are characteristic of TDD, that you slice the functionality and you build it a piece at a time and you adjust between slices. So the kind of the typical cycle time in TDD will be less than 10 minutes. Probably a lot less than 10 minutes for a refactoring. But they're saying that, yeah, with the agentic AI writing the code, my cycle time is the same or even faster now, which is very different from traditional development. But it's still recognizably TDD, I think, even though they're not writing the code by hand.
So I just want to call out some kind of terminology. I think there's a straw man going on here. When we talk about spec-driven, I mean, TDD is entirely spec-driven. The spec is executable. You start with the spec. You write it in Python or Java or whatever you're going to be using. And then you or some genies or something produces some code that satisfies that spec. And then you might, if you like a tidy kitchen, do some tidying up of that code while it still continues. So spec-driven doesn't necessarily mean, and so I want to separate the idea of using a spec from this idea of one-shotting. So one-shotting is you write the whole spec and you say, go on then, genies, go and do your magic. And then you come back and you have a product. For the kids, V model from the 60s, I believe, or possibly 70s, was this. It was roughly a 2-year cycle because you do a release every 2 years because you were like, cutting edge. And what you would do at the point when you were writing the specification, you had your high-level functional spec, and at the same time, so business requirements, and at the same time you would write your high-level testing requirements, testing plan. And then as you got into more detailed functional design, so high-level functional design, low-level functional design, you would then have corresponding tests for those. And this V, it was sort of called a V model, so you'd fill in the V, you'd meet at the middle, write the code, and then make sure it all worked. And the original scope for this was 2 years. Now, if you look at what you're doing with TDD, it's the same thing, but it's 20 minutes, right? So it's still the V model. The spiral model, which was its contemporary by a guy called Barry Boehm, was the idea that you would design something, you would then do your analysis, you'd then come out with the technical design, the functional design, you'd implement it, and then you'd test it. And it was like a little circle. And his idea was that you had these concentric circles, like a spiral, where you'd start in the middle and you'd end up with the product. And again, each go around the spiral would be 18 months. And again, if you say, well, actually, BDD is that, but it's 18 minutes, right? Then we're still doing V model and spiral, and but just the timescales have massively condensed. So I guess in terms of like, what are we doing with spec-driven? I think the idea of one-shotting for a prototype is brilliant, right? And it does. It's Eric Mayer has this wonderful language he uses. He talks about democratizing. So he likes to democratize programming, democratize whatever. And one-shotting with prompts democratizes that prototyping activity for non-technical people who've got a bit of an idea. But you absolutely do not want that for evolving code. So going into code that exists and make it do a new thing as well, or make it do a thing differently. For that, you need very different guardrails. And we're right back to TDD again.
Yeah, so I agree with everything being said. And I think that it's definitely not going back to waterfall. It's, if anything, it's becoming much more agile. And to follow up on all the things that has been said, to me, the code now is a bit like metal. Metal used to be hard to get by and difficult to work with. And when you made something in metal, it was made to last. You probably have something of metal from your grandparents, but the metal that we use right now, we just throw it away after we've used it once. If we look at the garbage cans, it's just throw away. Well, it's reuse, of course, because we're in Germany, but you know what I mean. And I think code is becoming that, and I don't know whether that's good or bad. It could be a way of democratizing the code. It could be a way of spending a lot of energy for nothing. But it is interesting that the whole value of code and the whole blood, sweat, and tears about code is changing, I think.
Maybe just to like, unless you want, I just wanted to, with the spec-driven, just for the record, I think there's no satisfactory definition of the term spec-driven development right now. So I actually don't like talking about it. I try to figure out what it is. That's why I wrote the blog post. But I just had to, like, with like a lot of discussion, convince my colleagues last week to not put this on the ThoughtWorks technology radar again, because I kept saying there's no good definition for this. It's just like something people say, and everybody means something else by spec. So, and that's also one of the challenges right now in the space, because it's moving so fast that people come up with these terms, and then immediately there's like 100 different definitions of it. So yeah, I wish the term would just go away, to be honest.
Yeah, and for me it sounds a little bit like, just because we now call it spec, we think about waterfall, but if we would call it user story, that someone takes, understands, then plans what to do and then implements it. We are doing that for years and we call it agile, but as soon as we don't call it any longer user story but spec, we say it's waterfall. So I'm like, we just do the same as we did before, in a different technological way, but it's, for me, it's still the same agile way. But if you believe writing a book of specs and user stories and then give it to a team and come back half a year later, and for sure you will not get what you wanted, right? So, and these iterative cycles need to be still there. They are just getting faster, hopefully.
I just want to add as well, as someone who spent at least the first 20 years of his career writing code for money, and the latter 15 or so talking to people about how they can write code for money, I don't care about code. I care about what the code does. I care about the business capability I get from code, and if you can give me that business capability with less code, you win. If you can give me that capability with no code at all, you win at programming, right? So I am absolutely fine with a an agent or a LLM or a human being throwing away code and rewriting chunks of it, if that will get to the goal faster than trying to manipulate the code that's already there. The code is not an asset. The code is the liability. The business capability is the asset. So if I can get something that can tank through that code and make it be the thing I want it to be, I kind of don't care what's doing that.
That's a good bridge, let's say, or segue or something to my next topic. I'm jumping a little bit here in my list, but I think that fits very well. So it's about trust in code. The first thing you hear always when you discuss with somebody about AI-generated code is, can I trust it? Do I know whether that's the correct code or it's not the correct code? Do I review or do I need to review each line of code that I've written there? Actually, when thinking about it, I realized that this is not a really new problem in our industry. I have discussed that many years ago regarding, for instance, open source libraries you're using, which is also part of your system, and where you need, or where there was the discussion whether you need to read every line of code of your open source library that you are using. That said, those libraries were usually crowd tested, so you use them and hope that somebody else already found the bug that was risky. But still, we have generated code, and how do we create trust into the code that a machine generates for us? How do we do that? Any ideas?
Birgitta, explain the concept of harnesses. This is just a breakthrough idea that's appeared in like the last couple of weeks, and I'm so excited about the idea of harnesses.
Yeah, it's maybe not a breakthrough idea, but like it's like now a name that is coming out for it. It's just like basically not just giving the agents like the feed forward of like, here's like our coding conventions, here's how we want our code to be structured and all of that, but also the same as developers, just giving the agent direct access to the feedback, right, to the static code analysis and all of that type of stuff. And I was just saying to Emily before that, I was for like a long time always a bit dismissive of static code analysis because it's not the full guarantee that the code is actually good and all of that. But then like some years ago, I had a junior developer on my team who like we paired with her a lot, but then also she was working by herself to like, build up, that, as a junior, you can code without like a senior next to you, right? And she had access to like a Sonar setup, and it was actually super useful for her, right? And then I was like, oh yeah, right. Like I forgot this can actually catch a lot of things that you might be doing wrong. And I was thinking about that now when there's this like more and more chatter about building custom linters and making more use of structural tests like ArcUnit style. And also the fact that these types of things we can also now custom build a lot easier. So we can build a lot more custom structural tests and stuff like that. So this would all be about the internal code quality mostly, right? And I think maybe that might even make agents build better modular code bases than humans do. So it still doesn't solve the problem of a lot of other quality attributes or like just is the behavior there. But there's definitely like a lot of like more traditional stuff that we can throw at the agents and make like a better feedback loop for them that will increase our trust. And then depending on the use case, we can decide if that harness that we have is actually good enough for the risk profile of the use case that we have or not. And so all of those things will determine how much confidence I have in the output.
I just have something very short to say, and that is that every time we need to transform something, people want it to be perfect. So, but can it solve this? Can it solve this? Will this be perfect? And what I normally say is that as long as we don't make it worse, and I think the fact about trust, we already, as you said, we already have that problem. So I don't think that we should expect it to be perfect, because it can never be and it never was.
Most of my job as a technical coach has been helping developers to write better quality code. And it's a very skilled activity, particularly when you have a very old, difficult code base, to be able to raise the code quality. So it's so exciting to think that now you can get these deterministic tools that can measure the code quality, at least a minimum, kind of make sure it doesn't make the worst mistakes. and it has a ratchet. It can access refactoring tools, proper refactoring tools. It's starting to actually get a wide variety of refactoring tools. And this idea that actually the code quality can be improved without human skill, with just static analysis tools and refactoring tools and an agent in a loop. That is amazing if that's actually going to work, and I'm really hopeful that it will.
I think the risk, and this is going to keep happening, right? And I'm going to keep saying it, and it's still going to keep happening. The risk is that we're anthropomorphizing a machine, right? Claude doesn't give a crap. Copilot doesn't give a crap. Not because it doesn't like you, because it doesn't have the capability to give a crap. That's not there. Claude can't program. It doesn't know how to program. It knows how to produce things that look like code in response to things that look like questions. It has no domain awareness. When you're doing a financial billing system, right, it doesn't know the domain of finance, the domain of billing. It doesn't know any of that stuff. It just knows how to produce convincing-looking output based on convincing-looking input. And what we're doing is we're getting better at more convincing-looking input, which constrains, and again, the feedback loops mean we're more likely to get convincing-looking output. I can't not mention Hanlon's razor, right? Don't ascribe to malice what can be explained by incompetence. And the key difference, this LLM that is not a person and will never be a person, is not a junior developer, right? The LLM, there's two things about the LLM. One, it doesn't care about your code. Two, it will not learn, it doesn't want to learn. It has no volition, right? A junior developer is really, most of the ones I've worked with and hired and trained and whatever, is desperately eager to learn and grow and practice and do those things. And they're going to mess up, and they're going to mess up again and again and again. But you can think of them as like chaotic good, right? They're finding their way, but they have good intentions, whereas an LLM is at best chaotic neutral, right? It will never care about your thing. It can't be made to care about your thing. So I think that's kind of where we're at.
I just wanted to, I wasn't trying to say that the LLM was some kind of junior developer, just that you can get this ratchet effect.
Oh yeah, no, sorry, yes, I wasn't suggesting that you're, yeah.
To raise code quality, and that I haven't really had before. It's some deterministic way to raise code quality.
It's interesting. What I love, and someone who I would love to be able to cite her, because I can't remember who it was that said it recently, that if you take the Venn diagram of things that improve developer experience and things that improve agent experience, it's a circle. And I thought that was a wonderful observation, is we're now investing in things like static analysis, things like tooling, things like whatever else, documenting stuff, writing down how we do things, being explicit about our ways of working and our code style and our, for a machine, in a way that we've never, ever invested this much in the human beings around us. And what does that tell us about us?
Well, yeah, what I'm missing a little bit here in the discussion is the aspect of trust is we were talking about how do we deal with the machine and so on and so on, but trust is not the problem of the machine. As you said, trust is our problem. So how do we get to a situation where we say, okay, we can trust it? Or can we say, okay, we don't trust the stuff that's there?
Well, I think Emily nailed it with this idea of ratchets. I think that is so critical. Is, you've got this thing, and the elephant in the room about the elephant in the room is that it has a chronic memory problem, right? It will forget things you've told it. It will forget very important detailed instructions you've given it while you're talking to it. It's called compaction. It's baked in. You can't not have this, right? And if you know what you're doing, you can decide when it's going to forget and when you're going to have to summarize everything it's ever heard. Or sometimes it will just do it. And there's that wonderful / heartbreaking story of a senior AI engineer, like a director of engineering, who was using like a Claude bot or whatever to manage her email. And she said, right, the one thing you must never ever do is delete email. It went, okay, and then it deleted her entire email archive. I told you not to. Yeah. Oh, did you? Oh, there's a thing. And she said she ended up doing this kind of walking on eggshell things with the one machine she still had that had her email on it to try to get it back. And You know, this isn't malice. This is pathological incompetence. So given that is literally baked in, that's part of the design. Hallucinating is part of the design. Compaction is part of the design. We have to build these checks and balances and harnesses to manage if that's the tool we're going to use.
But it's again about risk assessment and the use case, right? Like in this case, of course, I would not give an agent access to my email, right? Like especially not write access or delete access or any of those things, right? Yeah. So in the case of like coding, like I agree with everything you said. Like it doesn't care about the code and all of that. But if it does the thing that I need, do I care that it cares and that it's a machine and not, you know, like I also don't think we should anthropomorphize it. And it's like easily happening because the large language models are trained on our language. So that's why it's also like all the things that are good for us in the code are good for the model because it's trained on how we've been writing code, right? But yeah, I mean, does it matter why that is the case if it gives me something useful, right? And the risk assessment part, that's the like, what's the use case? Like how much footprint do I give it? Like impact what it can access and stuff like that. And that's kind of like then how you wield the tool, right?
Okay. Well, talking about learning and skills and so on, coming to one of the questions that always comes up again after reviewing the code is the, and Kevin talked about it today too. Are we going to get more stupid because we are using those AI agents? Is it like GPS that lets me not being able to navigate a city without looking at a machine? Of course, also connected to the question, what do we do with the new developers that might take the easy way and Dan, you just said you had developers that are always eager to learn, but what if they are not eager to learn? What if they are just using it? Silvia,
Yeah, I think I recently had an experience with one of our students and he tried out some new technology and it looked good, it was working, and at one point it stopped working. And I asked him, okay, what did you do? I didn't know anything about it as well, but I realized he didn't even have a clue how to start debugging this thing. He doesn't know anything about it. Even not something like system out println, right? So the very most basic thing that I would expect works in every technology. He was just like, I tried again and again, and maybe he would ask again and again his chatbot, but nothing happened. And I'm thinking, this is something, maybe we need to find a way to teach people that explicitly again, but they will not learn it by themselves. Like, we were like, with compiler errors, we started and we were like, okay, how can I start and go forward? And they don't have the problem now because they just ask, so how can I fix this compile error? And they copy paste. And I think it was a similar story when Stack Overflow comes into the play, right? So you could start copying from Stack Overflow, but you still realize that it's not working forever. So there is something changing for them, but I think they will need to learn how to debug and how to analyze a problem when the machine cannot help any longer.
The short answer is yes.
Shit, I forgot my question.
Okay, so your question was, will people still develop these skills or will they forget them? And the short answer is they will forget them. And I hope not. But as I said, being a teacher for teachers in computer science and also talking to other people who are teachers, not just at the university, but at different kind of, at least in Denmark, there's different ways of being educated in IT, and there are some schools where you are learning how to program based on a specification, and there are some schools where you learn to create the specification and things like that. And we are really talking about, I don't know how to translate this to English, but in Danish we say fagsorg, and that means content sorrow or something like that. That some of us are really, really sad that some of our skills that we've worked with for so many years might be forgotten. And if we think back to other things that have been taken over by machines, if we call this a machine, that they have been very sad. And at the university that I am at, we are working in 2 different directions at the same time, and I don't know where we'll go. One direction is we will make sure that when they hand in something, they have to hand it in orally, so they have to explain what they've done. And when they go to the exam, they do it with paper and pencil, and they cannot use the computer. So that's one direction. But we have another direction, which is debating, do we even need to teach them these skills? And if we don't, then the whole education is going to change tremendously. And what we're going to teach them is something different than what our wonderful professors have been talking about for 30 years on stage. And that's really scary, and I don't know what the answer is. But it's like 2 out of 3 of my children are either computer scientists or becoming that. So it's a very personal question
right there.
Yeah. Bad parenting, we're both computer scientists, yeah, sorry.
I want to speak directly to the question. Are we going to get more stupid? I think it only matters losing a skill if it's a skill you're ever going to need again, right? And if we are, and I think we are, exactly to your point, we are at risk already of losing skills we are still going to need, that's a problem. That's a material problem. I've been in software for 35 years, I suspect as long or more longer than a lot of people in this room, but I'm still pretty, I'm still pretty new. It's quite an old field now. So who here is any good at punching cards? Who has a card hole punch? Right, there's a skill, and it used to be an important skill. How fast you could punch holes in a card was how fast you could program, right? What about changing the paper in a teletype? No, you know the TTY, the letters TTY, when you have a TTY, that's a thing. That's a physical, mechanical thing. Who can program in machine code? No, not assembler, machine code. Ah, gotcha, right? So again, some of you will know assembler and some of you need to know assembler. Most of us don't. Practically no one will know how to program in machine code. So there are skills where, as the technology has improved, and again, Taichi Aino, the founder of the Toyota production system, he has this wonderful term. He calls it automation. And automation is automation with a human element, right? And for me, any technology advance, the ones that wins are the ones that allow humans to do stuff better, to make it easier for them to do things, not to replace them. And if you look at the most successful technologies in history, they allow us to do stuff, whatever that stuff is, medicine, research, science, climate, whatever it is, right, better. Sometimes not entirely better, right? But by and large, they augment humans, yeah? So if we're losing skills where we're likely to still need them, and we are in a world of COBOL, right? COBOL is still one of the most prevalent languages. Whatever code is out there has an enormously long tail ahead of it. And so the ability to go in, manipulate code with your hands, that's not going away in my lifetime, probably in the lifetime of anyone in this room. And if we allow those skills to atrophy, right, we're in trouble. One other thing, and then I'm going to shut up. One other thing I think is really key, and I'm really excited about this, and I'm looking to Aino particularly, and Emily, who are the people in the world who are bringing up the people in the world, is the word native. So I've got a 3-year-old son. He is mobile native. He's never lived in a world without mobile technology. He got disappointed when he was 2 that he couldn't do that on the TV screen and it would do stuff. Right, because it's just like a little screen, but it doesn't work. Yeah, we're all old, right? All of us are old. I'm really old, but like all of us are old. Yeah, the kids coming through now will never have been in a world that didn't have AI. They will be AI native. They will be Gen AI native. They will think about problems differently than I can. I can probably learn to do it, but I'll keep falling back on my old artisan programming habits. Yeah. And that's exciting, right? So let's bring those junior engineers, let's give them the space to learn this new world and make sure they can still drive with a stick shift.
I disagree on 2 points.
Nice.
I'll make it short. One is, I don't think there'll be a long tail of the programs that we do right now. It's so easy to go into a really old program and find the smallest thing. So the truck number is dead as a concept as well. I don't think the code will get old, but that's just, I mean, what do I know about the future? And the other thing is, if we look at the young people who are mobile native, they're still falling into a lot of the traps that are because of the mobile. They're still falling into the sexual predators. They're still falling into losing their parents' money. So yes, they can use it, but not in a safe way. So that's all I wanted to say.
Yeah, I think one of the tricky things is like when we draw on like history from computer science and then the assembler comparison and all of that, right? Is that we've always gone like up in the abstraction level, but like real abstraction in the sense of that we've had deterministic tools that add the technical details and translate from the new abstraction level to the next abstraction level, right? But this is not the same thing, like the natural language thing, because we don't have like a compiler that translates to the level down. Like I always say, it's kind of like moving to the side because we can use LLMs on all of the abstraction levels. Like I recently talked to Uwe Friedrichsen about this, and he said like, yeah, it's not a closed abstraction. It's not closed, so we cannot forget like what's underneath. And that goes to what you were saying. Like we'll still have to a certain extent actually edit or understand the existing code, but we don't have as much practice anymore for like what's potentially going wrong, right? Like so. How do you build up the mental model, in your head, the shortcuts, like to understand everything? I read this article a few years ago on like what programmers need to learn about learning, and there was a thing there about how you learn those shortcuts, those abstract concepts, and maybe Aino is nodding, she maybe knows about this better than me, by actually going detail abstraction, right? You write the syntax of a for loop, and then you do that a few times, and then you start understanding the concept of a for loop, and you have a shortcut in your head. But then how do you learn those like high-level abstract things if like everything's still running on code, but we're not? Yeah, so I don't know. It's not an answer to the question what we do, but and maybe my last point. There's like. Arguably, I would say like Claude Code itself right now is a really good example of a piece of software that is being built entirely by people using agents, not typing code anymore. And it's a piece of software that has maybe had one incident over the past year that was quickly resolved, and it works really, really well, right? Like from what I understand, I think like the people on the Claude Code team are all really, really experienced developers. And I think that is currently covering up some of the what the situation will be like in maybe 5 to 10 years, right? The teams that are really successful with this at the moment are like really experienced and have all of these mental models in their head. And I also wonder, and there's a lot of technical descriptions when you prompt, right? It's not just the functional stuff. It's a lot of technical stuff. So yeah, I really wonder about what that will be like in a few years.
Can I come in on this
Please.
a little? Engineering skills. I'm convinced that we still need engineering skills, even when we're using an AI to write all the code. And the reliable way that I know to teach people engineering skills is having them build stuff and toy projects. And I'm looking at my daughter, she's like 17, 18, and she's building things with Arduinos and wires and 3D printing stuff. And she's learning engineering skills by doing it. And I think that those skills are transferable to the AI age, but I think the way we know to teach those is not using the AI. So that's the interesting part to me, is that I think students benefit a great deal from not using the AI to learn engineering, but at some point they need to learn the AI specific skills. And I'm not sure we really know what those are yet.
Well,
oh, maybe you do.
No,
maybe let me mix some opinion with a question about that. Sorry, I know.
You can just talk over him.
But because for that point, I think curiosity is always the key to learn new things and wanting to understand something. So the opposite of what you, Silvia, described, well, I got a solution, but I don't know how it works, but however it works, that's just the opposite thing there. And my experience, very, very personally, is that if you use the LLM stuff to really dig deep into what is it actually what I'm seeing here, please explain that to me more and more and more, like you would maybe look into whatever dictionary or something to understand the word, then you can even learn more if you go this way. Sorry, was that something you want?
Yeah. So yes, the LLM can help you to understand a topic and help you to research it, and that's useful. You need understanding and knowledge, but a lot of engineering is practical. It's doing it, and it's fiddling around with wires, and why does this break, and how do I debug that? And and that practical, it comes from experience, not from talking to an LLM.
Just very short. I got the microphone. So again, in the university, in teaching, if we're looking at the motivation for students to learn, I think we're a bit biased up here and maybe down here as well, that we are learning because we're curious, we want to improve our skills. But about 60% of the students are there as a means to an end. And that's a very different motivation, and it creates a very different way of working with it. And the way that I try to explain it to my students is the difference between just-in-case and just-in-time learning. So what we try to do at the university is just-in-case learning. Just in case you need to understand the compiler, you need to learn this. Just in case you need to understand this type system. But what AI can give you is the just-in-time learning. So just in time to hand in that assignment, you can learn that. But if you look at the deep neuroscience ways of learning, that's not real learning. But let's not go into that here.
I just want to reinforce something that Emily said. So there's a model that's been kicking around that sort of education circles for decades called VARC, visual, auditory, reading, and kinesthetic. And the idea is that there's different modes of learning, and some people are visual learners and they like pictures, and some people are auditory learners, they want to hear stories. Some people like to read and do self-paced stuff, and then some people kinesthetic, they like to interact with this thing. And it's a very appealing model, and it has some very bogus research around it, and it turns out it's complete nonsense. Right? It absolutely falls apart as soon as you start to touch the edges, because it turns out that everybody is a kinesthetic learner. Right? You're a kinesthetic learner from birth. The way you learn anything is by interacting with it, by playing with it, exactly to your point, building with it. And if I ask an LLM for the answer, I'll get the answer, but no learning took place. And even if I ask an LLM to teach me, still no learning takes place, right? It's not until you are interacting with the thing, making the mistakes, because learning is about making mistakes and understanding why that thing was a mistake, getting that experience, putting in those hours, and then going, oh, right, okay, this thing makes sense now. Write the for loop, understand a for loop, write another for loop in a different language, understand, oh, right, now I get iteration, this is making sense. And without actually getting your hands in there doing stuff, no learning is happening.
I mean, one of my hopes is that that will be the thing that will be happening, that the next generation will learn through the pain of making mistakes the same way that we did, and then they will be forced to understand certain things, and hopefully that period of time will be as short as possible. But yeah, there will be, like I did, I made mistakes. I once during an internship deleted the whole production database because there was only production.
Put your hands up if you ever deleted the production database.
It was the user database as well. Yeah. But this was a long time ago. They shouldn't have let an intern, mess around in the PHP my admin. Anyway, I learned from that, right?
Okay, learning is one of the human aspects. Another one is how do we actually work, and how would teams maybe change or not change? I don't know. That's another discussion that I hear quite a lot. I think Joerg Mueller talked about that last year in the keynote here. He said, well, we will probably be moving to other team sizes, which might become smaller. There's also another aspect that I actually hear a lot when I talk to people that work in an environment or try to use those agents, which is they don't actually pair program anymore. They mostly sit alone and try to work with their agents somehow. So what are your thoughts about how will work life and teamwork actually change if it comes like it comes? Maybe everything will be back to normal in a year, but it doesn't really look like that. So what do you think how teamwork will change, how team sizes will change?
All the things I'm thinking about that are disagreeing with each other.
Okay, so what are some of them?
Okay, so one is, so one part of me thinks the teams will definitely get smaller because we can use some agent as a team member and we can use those to learn. I can see that also coming back to the teaching, that the students can use it to learn in the same way as pair programming and peer reviews would be good. On the other hand, I'm thinking that it might be easier to cope with the big cognitive load of a big team if you have the help of an artificial intelligence in some way. So those two things are disagreeing with each other. I'm also thinking that it's a shame that people will start using an AI instead of pair programming with another human being. But on the other hand, I know a lot of people are suffering in the pair programming style, and they might actually benefit from just sitting with the computer. So I'm completely torn about this. I've got a lot of other things going on in my brain, but I'll leave it with that.
I can talk about. I don't think we've solved this. I mean, the experience of working in an ensemble. I do a lot of working in an ensemble as a technical coach, and it's such a good forum for sharing knowledge and communicating about code and teaching, and there's so many benefits to it. But my experience of sticking an AI into that forum as an agentic AI is that it somehow collapses. If you're not careful, it just collapses the whole conversation, and it all turns into us staring at text scrolling past on the agentic AI, and suddenly we're not communicating, we're not learning, and this AI is turned into the most horrible pair ensemble member ever who just takes over. And I don't have any really good solutions for this yet, but the trend at the moment is very much towards me and my AI or my fleet of agents, and suddenly we've lost all this collaborative programming, and we've got to get it back. I mean,
I had yesterday evening an interesting discussion, and one said, if I'm programming with other people in an ensemble, mob, whatever you call it, he said, it's even better than AI because the people are foreseeing which problems will come up and they're already solving the problems. This is what the AI can currently not foresee what will be the next challenges coming up because they all know where it will going. So this is something I think really interesting. But on the other hand, he said, but when I'm alone, then it's better to have someone next to me. So if sometimes there is no ensemble available for whatever reason, I'm working later than the others, whatever. So I think you're having more flexibility maybe now. You have a pair if you want or you need one. But yeah, on the other side, I'm thinking, yes, you can have smaller teams, but your PO is also speeding up. So he's producing more user stories, and so maybe you still need the same size amount of developers. On the other hand, you can maybe easier start something new with 2 developers already, which you have never done in the past because 2 were too small, but now you can start something. So I think there are opportunities to have different team sizes, but still you will have the team sizes you had before maybe as well. So maybe there's not this one single answer.
I mean, there's these different scenarios that we can play through, right? Will teams get smaller and then potentially the individual cognitive load will go up, or will we give existing team sizes more topics to work on and then the whole team's cognitive load will potentially go up? Or will there be something about teams and systems being able to collaborate with each other easier or something like that? I think in part it will depend on this kind of breakneck speed and throughput that people are trying to do right now, to if that will collapse at some point, or if we will figure out some way to do it sustainably, and if that even makes sense, right? All of this throughput, do we even want that? What is the Goldilocks speed and throughput that actually makes sense to create value and to not burn people out and to so I think it will depend a lot on that. And I mean, there's also organizational things, right? You can't make a team so small that you can't be on call anymore and stuff like that, right? So that also plays into it. So similar to Aino, I also keep going back and forth. There's so many pros and cons to different scenarios, or yeah, it's there's also, of course, everybody thinking now every developer just does all the different jobs and everybody can do anything, right? Everybody can do design and the product owner can code. And yeah, definitely, I think it would be good if more people would experiment more with this. I think a lot of people are very careful about it right now, but there's not a lot of data yet, I think.
So when someone asks me something like this, I go back to first principles. The question I ask myself is, so we're talking about how team sizes are going to change. The question I ask myself is, why are they the size they are now? Right? Because they weren't always that, and there isn't. I mean, I know there's some religion around, 7 plus or minus 2 nonsense. But the point is, if I go back in history, even for relatively recently, you'd have the DBAs over here, the systems folks over here, the functional people over here, the UI people over here, in completely different teams, maybe organizations, either in silos or whatever. And they weren't there because we thought that was the right thing to do, and now we think it's a different thing to do. A lot of it is because of tooling and because of language change and because of just the environment we're in. Suddenly things where we would have had to taken something and split it into pieces and farm those pieces out and then bring them back together in the end, which is how we used to do software, becomes tractable for me to say, hey, Birgitta, can you add this field to this report? And she has the skills to make the UI change, make the functional change, make the calculation change, make the database change, and make sure all the glue in the middle is working, and write tests for it and be confident that it's changed, right? So that's now a thing that a human being can do, or a pair of human beings in a small team. And so I don't necessarily think we're going to get smaller teams or bigger teams or anything like that. I think the nature of work is going to change. So why do we have user stories, right? Why do we work in small chunks? Risk. It comes back to risk and blast radius and how much stuff we can hold in our heads. By the way, complete sidebar, we're doing cognitive load all wrong, right? Everything you think you know about cognitive load is completely wrong. Ask me later. I get really cross about this, but not now. We only have 8 minutes and 30 seconds left to change the world. So I suspect what's going to happen is we're going to be more ambitious in the size of a unit of work, because we can be, right? We can say, I want to make this significant, I want to implement this entire feature because I can with my little team and some super-powered robots in a way that would have taken weeks or months or would have needed to be split up into much finer slices before. Your elephant carpaccio becomes more like an elephant pasta, right? You can just take bigger chunks of it. Sorry, vegetarians, and anyone who likes elephants. I did want to mention though, so domain-driven design is a real passion of mine. And the core idea in domain-driven design is the goal of what we do as people in organizations doing stuff is to understand what the stuff is and to figure out ways to meet that need. And by modeling the domain, and particularly there isn't like a perfect model for any domain, it's like, what's the model for the domain to solve this problem? By modeling the domain, the software is kind of a side effect of that. And this comes back to learning again, right? So the more we learn about the domain, the more we can articulate about the domain, the more we can build little software constructs that are our projection of what we understand about the domain, the more problems we can solve in that domain. And so the point is the learning. And if the way in which we're engaging with work isn't doing the learning, isn't doing the knowledge crunching, then we're not going to be able to solve those problems.
Wow. I'm thinking about whether I asked the last question or not, because I'm not sure we moved in the right direction, but I still do it. We were talking about teams, we were talking about team sizes and communication with other teams and so on, and our agents. And one thing that comes to my mind when I talk about that is a topic that we always mentioned at this conference, Conway's Law. Will we, I mean, I think Conway's Law will still hold up, because we will still have some kind of communication, and this will still shape the structure of our architecture and so on. But will maybe we need to look differently on Conway's Law in the future, because we have, if I anthropomorphize, or however you say that in English, the agents. Will it change? What do you think about Conway's Law in the future?
I want to slightly derail this to go back to something Aino touched on earlier, and I think is absolutely vital to this conversation. Conway's law is already happening. Conway's law, for those who don't know, Melvin Conway, 1967, he wrote a wonderful paper, and he said, but what he'd observed is that the architecture of systems in large organizations tend to model the communication structure in those organizations. So it's nothing to do with org structure, it's to do with how people communicate. And for me, the glaring illustration of Conway's law is that the information in an LLM is a projection of the communication of the types of people and organizations that built those LLMs, which takes us right back to bias, takes us right back to toxic. There are live court cases right now where I think it was Google Gemini, I'll probably get sued for this. One of the big LLMs told somebody to kill himself and gave him ways to kill himself. It said, well, you should probably end it. Right? This wasn't even he was already thinking that and it gave him, it made the suggestion. Right? And this is baked into the stuff we've got. And Aino's point, when I was talking about kids being like cloud native or whatever, I'm talking about the folks designing systems having always had that. It's like being water native and saying, what do you mean you have a well? I just turn on the tap. That's what I mean. Obviously, the things you build with that, yes, we need online safety. Right? We don't need the Online Safety Act. That is massively misplaced in the UK. But anyone who's from the UK and just going, why are you doing this? It's very, very easy for politicians to get derailed totally by this stuff. But we have, apart from all the ethics of should we be running these things in, energy-hungry, water-trouncing, whatever places, so apart from the ethics of even running them, the stuff that's in those models, the content of those models is entirely Conway's law. And it is hiding in plain sight, and it is terrifying.
Very good point. I like that. Anybody else got any thoughts about that?
And maybe a software-related example of that is that they all assume pull requests because all their training data is full of the concept of pull requests. That is a communication pattern that we have, right? So.
They also assume that all code is just like the code you find on GitHub, which is really heartbreaking.
Yeah, open source maintainers do have a problem. We discussed that, on that. How do we deal with all these AI slop then in the future? All the pull requests that are generated and overwhelm the people that try to maintain the systems?
Well, I mean, the famous example is the curl stopped giving bug bounties because they got too many spurious security pull requests, whatever things. So yeah, I don't think there's a lot of these problems that the AI, being so cheap now to generate code, to generate pull requests, and there's a bunch of problems being caused by that. And I don't think I have the answers, I'm afraid. So, yeah, it's clear that we're moving into, it's creating as many problems as it's solving, probably.
So I'm running around facilitating retrospectives for a lot of different IT companies around the world, online and not. And one of the things that we're really discussing right now is how do we use AI within our team? And for those teams who are not already discussing it, I'm trying to encourage them to discuss how are we using AI in our team. Trying it out, as you said, Birgitta, try it out, everybody, and talk about your experiences, talk to each other, talk about how you use it, how you want to use it. Because the things that I see right now is it's really bad in the team if some people in the team is using it in one way and other people are expecting them to use it in a different way. That's the worst. So continue to communicate and try it out, I think, is what I would say in general.
Yeah, and that kind of architect I spoke to recently was like monitoring who was using the AI the most, and it was the most junior developers were using it the most, and that was kind of worrying. It's like, there needs to be some consistency in how development teams agree to use these tools, because otherwise they're going to be delivering slop to one another, and it's going to cause a lot of kind of the same kind of tension that the curl project is getting now. I'm not reviewing this. That's a 40,000 line pull request. Go away. Yeah.
it comes to my mind something you mentioned some weeks ago, Birgitta, like, is the value they are creating worth the money we are spending, right? Because right now it's cheap to create all these pull requests, but how long will they be as cheap as they are? And like, I think maybe currently it's nice just to try out everything and just do all of that, but the question is how long? And we're still spending time to do things, and the question is if the money answers at one point maybe the question, and we don't produce just anything because we can, but because it will be too expensive at one point. It's at least a tiny hope at one point that it will become too expensive.
I don't have an answer to the question. I have a really, what I thought was an insightful reframing of it, which is Mitch Hashimoto. He wrote all of the he started all the HashiCorp stuff, so Terraform, Vault, Console, all these amazing bits of software. And recently he's been writing a terminal emulator called Ghosty, and I use it and it's brilliant. And his observation, he said, particularly in the PR world of open source, is that we've had to move from a default accept model to a default deny model. Mm-hmm. So the default is someone submits a PR, they do it with good intent, positive intent, and there's almost like there's a proof of work element to it, right? They had to do some work to to make the change, fill the pull request, fill it in. So you can generally assume good intent, right? Or well-disguised malice, yeah. But it's a human being and they're doing stuff. When it's all AI generated, then you have to assume the default has to be deny until a PR contributor can prove its worth, if you like. And he's started a new open source project called Vouch. And Vouch is effectively a web of trust for open source projects to then vouch for contributors. And you can either vouch for someone who's a committer or a contributor, or you can accept someone else's vouch list. So I go to Emily's project and she's got a really good vouch list of loads of contributors, and I subscribe to that list. So his counter is to start creating a web of trust where we assume default deny, and then unless you're vouched for. And I don't know if that's the model, it's a model. I suspect there's going to be an awful lot more hard thinking in that space.
Thank you. One more shot. Yeah.
Yeah, and it's a little bit, I don't know, if, heartbreaking or something. I mean, these models and the coding capabilities only exist because so many people spend so much of their free time over years like contributing to this foundation that we have, right? And something like this vouch model might actually make it more exclusionary and harder for people to get into this, to contribute and all of that, because you have to like get into this network and you have to like, somebody has to vouch for you at some point, right? And so in a way, it's like also, heartbreaking in a way, right? Yeah, I don't know, sorry, that...
Yeah.
Those have to be the last words
I'm just
now?
trying to find last words, and I'm now getting from default deny mode to heartbreaking, which is really, really low to get to this. Maybe I should have stopped when Aino said something about, try the things and learn the stuff and experiment with everything. Because it will change and we all need to learn how it will work. I'm trying to stick with that now.
There's lots of exciting stuff as well. Like that's
lots
of people rediscover their excitement in some stuff. So
thank you very much for that. Okay, thanks a lot. I think that was hopefully also for everybody here a very interesting discussion with some food for thought. And now enjoy some more drinks. Thank you.